Question 4, we have complex numbers. This z is equal to z1 is 1 plus I is a root of this equation. Find the value of p. So let's sub in the root, see what we get. 1 plus I for z, so 1 plus I to be squared, plus 3 minus 2i by 1 plus I, plus p is equal to 0. So this is going to give 1 plus 2i plus I squared. Then we're going to get 3 by 1 plus 3 plus 3i minus 2i minus 2i squared plus p is equal to 0. We have a couple of cancellations going on here. We have a minus 1 and a plus 1. And then we have a plus 2i and a minus 2i. So that's going to leave me with 3 minus 2 by minus 1, 3 plus 2 is 5. And then we're going to get plus 3i. And that will be plus p equals 0. We want p, so we need to bring them across. P is equal to minus 5 minus 3i. Part A. Part B, the Moivre, w squared is equal to this. So let z equal minus 1 plus root 3i. When it's w squared, we have two solutions. So n is equal to 0 and n is equal to 1 when we simplify down in polar form. So if we plot this to help us, and it's in the negative positive sector, so it's in here. So here's my complex number, and it's minus 1 plus root 3i. So I have a 1 and a root 3, and my angle. The tan of A is equal to root 3 over 1. So A is equal to 60 degrees. You should know this one. So my reference angle theta, or my reference angle A, theta is equal to 120. And then or, the modulus, or is equal to the square root of the straight side squared and added together. You see this is going to work out to be 2. So z in polar form is equal to 2 by the cos of theta 120 plus I sine 120. So w squared is equal to z, so w is equal to plus or minus z, or when n is equal to 1 and 2, so z is equal to the square root of z. Square root of z, so two solutions here for w. So when n is equal to 0, we're going to get of z to the power of a half. We're going to get 2 to the power of a half by the cos of a half of 120. And that's going to be I sine of a half of 122. You could just put in 60. So we're going to get root 2 by the cos of 60 plus I sine 60. They want each value in a plus bi, so cos of 60 is a half, so root 3 over 2. And then the sine of 60 is root 3, that's why I put root 3 in there. What am I doing? It's root 2. So it's root 2 over 2. And sine of 60 is root 3, so root 3 by root 2 is root 6 over 2. And that's I. So when n is equal to 1, we have the cos of, we'll just do a bit of rough work, the cos of a half of 120 plus 2n pi. So 2n pi will be 2 pi, so it's going to be a half of 120 plus 2 pi. And you know, you should know the rule, if it's a half, you're going up by 180, so it's going to be the 60 plus the 180 to give 240. So when n is equal to 1, so we're going to get root 2 by the cos of 240 plus I times the sine of 240. So the solution here when n is equal to 1 is going to be minus root 2 over 2 minus root 6 over 2. I. So my two solutions for 4b are these two. Last part of this, the Argand diagram shows the complex number u is equal to a plus bi. A and b are real numbers. Write the complex numbers iu and the conjugate of iu. Okay, iu, I by a plus bi. You should all know what happens when we multiply a complex number by I. It rotates 90 degrees through the origin, so we have ai plus bi squared. The b becomes the real part, so it's minus 1 by b minus b plus ai. So if we just put in our scale here, that's a, that's b, so minus a and minus b might be needed here. So minus b plus ai. Actually, I'm going to just put one more, put the minus b in here as well. About there, maybe a bit too far. Minus b, and if we need it along here, we'd have plus b, and then a here, and minus a here if we need it. Okay, what are we asked to do? Plot this minus b plus ai. So it's here, iu, and if we draw a line from here to here, you can see the angles in there are the same. We could get the slopes of these lines and show that it equals 90 if we needed to. Write the complex numbers iu and the conjugate of iu. Well, the conjugate of iu is minus b minus ai. We just changed the sign of the imaginary part, so minus b minus ai. Approximately the b's in the way here, but I'll just stick it here, you know where I'm going. That's minus b minus ai. Now plot and label the complex line, and so we've done that. We've written them in their simplest form. We've plotted them on the diagram, and then state a transformation or series of transformations that would send u to the conjugate of iu. So it's send u to the conjugate of iu. So here's u. We have to get it to the conjugate of iu is here. So a series of transformations. So rotation in origin gets me 90 degrees. So they're asking for transformations or series of transformations. What do we call this? A symmetry in the x-axis. Is that what they're looking for here? Symmetry in x-axis maybe? Or you could write find conjugate of iu. I'm not sure exactly what they're looking for here, but something along these lines.